Now a great pleasure to introduce our next speaker, Dimitar Sasselov. We're going to travel from the poetic mnemonics of Jacques Roubaud, and they lead us directly into cosmic memory, and it's the cosmic memory Dimitar will address here. Dimitar has been professor at Harvard since 1989, having arrived at Harvard Center for Astrophysics as a postdoctoral fellow in 1990. Between 1999 and 2003, he was the head tutor of the astronomy department. His research explores the modes of interaction between radiation and matter, from the evolution of hydrogen and helium in the early universe to the study of the structure of stars. He is today the director of the Harvard Origins of Life initiative, this extraordinary initiative which brings together astronomy and biology and leads to extraordinary collaborations, extraordinary dialogues with other scientists. Dimitar works very closely with the biologist George Church. He's going to tell us here about these recent researches, but he also works together a lot with visual artists. In 2010, we invited Dimitar for the Wolfgang Tillmans exhibition here to do a park night, and at that moment we actually discussed the transit of Venus. As far as I understand, we have this time another slightly more minor cosmic incident. There was, for 4 minutes, we had some solar incident yesterday, and the whole live broadcasting was interrupted. Maybe Dimitar is going to tell us why. But the main topic will be the cosmic memory. A very warm welcome to Dimitar Sasselov.
Good afternoon, and thank you for being here. It's a pleasure, and I want to do something different. Take you on a cosmic journey of memory, not human memory, but cosmic memory. If there is anything like this, maybe in the end we'll discover that there is no alternative, nothing which compares to human memory, but let's see. What is the cosmic journey? Well, it has to do with what we've learned from science in the last few years. I want to bring you to the edge of what some of those disciplines studying the cosmos and life in it have reached as revelations in the past few years. Israel Rosenfeld yesterday defined memory, human memory of course, as the synthesis of the immediate past with the immediate present. Immediacy, well, immediacy is an illusion of our human experience, but there is no such thing in the cosmos. And you know why? It is because of the speed of light being limited, the large spaces and distances in the world in which we live, even within our own solar system, let alone in our galaxy and beyond, are so vast that whenever we take a look at the starry sky, whenever we look even at the sun outside today, we only see the past. We never see the present. So there is no such thing as immediacy out there. And you can see it even on that screen right now. That's an image from a couple of years ago from the ultra-deep Hubble field. We call it the ultra-deep Hubble field because the Hubble Space Telescope took this picture by exposing for a very long time. And you see simultaneously galaxies which are in the foreground. These are, for example, the two large spiral galaxies on your left-hand side. And then galaxies which are as far as we can see today with our telescopes. The very tiny specks which are either visible or not quite so on that picture. Certainly on those screens you can see them, the most distant ones. So what you see there is an immediate snapshot, a photograph of the sky. But in fact, it is light that comes from very different times in the history of those objects, in those galaxies. The two spiral galaxies that you see in the front are light that came to us, and what these galaxies looked like, they were close to each other at that time, right about the time when animals and plants emerged on our planet Earth. So about 500–600 million years ago. These are the large galaxies that you see on your left-hand side. The smallest ones that you see there go back to about 2.5 billion years ago. So in other words, you see simultaneously an object as it appears 500 million years ago, and then other objects as they appeared 2.5 billion years ago. That was before there was oxygen in the atmosphere of the Earth. There was life on the Earth, but there was no oxygen yet. And so a lot of the life as we know it didn't exist. So is this memory? Of course it's not. It's just the reality of the world in which we live. In a naive or old-fashioned way, then, we would say, well, let's look for something, for some object or for something which is unchanging and immutable. And for our own human experience, we think sometimes of stone, and we humans presume that a memory can be set in stone. And in science, we mean this literally, as in this nice photograph of the Grand Canyon in Arizona, where you see the layers of rock which represent different times in the history of our planet. Rock layers, you see, record the ancient history of planet Earth, and we can read it. That's what geologists do. They read the book of Earth's history by studying the layers on top of each other. A nice way to record that history indeed. And we know how to do that for the first time on other planets. There is an image from Mars, planet Mars, Mount Sharp, Gale crater. This image was taken just about a month ago by the new Mars laboratory, which is there. And if you can see, I hope, it resembles very much Grand Canyon. There are all those layers of rock on top of each other. That is the same kind of history that is imprinted in them as we know here on Earth. And we're looking forward to the next 2 years to, in fact, study and read that history. So you have Earth, you have Mars. We now know that all rocky Earth-like planets in our galaxy will have similar histories if one day we can visit and read them. So you could say, well, there is a record which we could equate to what we call memory. But could we? Is this kind of rock memory both reliable and, in fact, durable? It turns out we now know that this is not the case, unfortunately. It may be reliable for certain things. It gives you some idea of what happened on our planet. It may be durable for a certain period of time, but in the big scales of time in the cosmos, it's not very durable, it turns out. Why? Because planets are not unchanging and immutable. They change. We live very short lives, and the cosmos seems unchanging to us. But planets do change. If you could live a life where you could see that transformation of the surface of the Earth over periods of hundreds of millions of years, you will see something like this. You will see a boiling surface which constantly changes, and where the continents of today are no longer there. They are subducted, they are metamorphized, completely obliterated, and with that, the memory and the geological record that goes with them. The only reason we actually have a good geological record for our planet that goes back to 4 billion years past is because there are little bits and pieces of rocks that somehow miraculously survive this process of constant recycling that happens on planet Earth. And we know that happened on planet Mars or any of those planets that we hope to discover in the future. So it seems that stone is not that good for keeping memory of the cosmos. So what about the stars? We always thought that memory can be fixed in the stars because the stars never change. But do they? They're actually not fixed, unfortunately, and even the ancients knew that. Because stars, you see, including our sun, they just go around the center of our Milky Way Galaxy. They constantly turn. With periods which take them on a single circle around the galaxy of about 250 million years. That, as it happens, is the same amount of time which takes the Earth to reconfigure its continents and recycle them. This is, of course, just a coincidence in time, about 250 million years. But it gives you a sense, it illustrates to you the timescales that are involved here. 250 million years is a very long time scale for us. But it's not a long time scale either for planet Earth or for the stars that circle in a given galaxy. It takes about a dozen circles around the galaxy since the sun actually formed. And in those dozen or so periods, the rocks on the surface of the Earth were mostly recycled. So in other words, there is no good scribe of history either on the planets or among the stars for us. And even the galaxies move too. So they don't preserve a history of where they were back when they started. The same way we have very little knowledge of where the sun and the earth were when they started 4.5 billion years ago. There is then the clusters of galaxies on a larger scale, but those then, as is now seen from recent images of what that web of clusters of galaxies looks like. I hope you can see it here. It is a large-scale web of the individual galaxies being tiny points of light on this scale. You don't see them, but you see the cumulative light coming from all of them in a sense of a web, which reflects a very distant past in the universe that we live in, but in a very simple way. These are just waves, ripples from the early time of the universe. Well, you could call it memory, but in a certain sense, it carries very little information, very little memory of something that happened back then. So where we are, those big and seemingly unchanging parts of the cosmos are not a good place to keep its history, it turns out, because they're changing all the time. But memory is motion, we learned yesterday. And indeed, maybe it takes a lot of change to make something unchanging and immutable, reliable and long-lasting. And there is a form of ordinary matter, as it turns, which is not the planets nor stars, but which is as old as planets and the stars, which could, we discover now, remember that past history and keep the memory of it. And we know very well what that form of ordinary matter is. We call it life. Life, as you see in this picture, is glowing in a tiny droplet of ocean water. And what is glowing are the molecules, which we call the DNA, in viruses and small single-celled organisms in that droplet of ocean water. That is the green glow, which looks like a stellar night image. That molecule, DNA, as well as its close sibling, RNA, are the molecules which are sort of memory storage devices in each and every living thing on that planet, even in those that are considered partially living, like the viruses, which are the tiny glowing dots on this photograph here. These molecules are sometimes compared to tape. DNA looks like a tape indeed. The AGCT of the different alphabets, molecular alphabet, which keeps a record of what a living thing is made of. Sometimes it's called a book or a manual of the living entity or of life. As we understand it now, it's more of a dynamic network, the same way we think of human memory, because of the phenomena of gene expression, which always happens in different ways, in other words, how this tape is read, and because of the phenomena of epigenetics and the way in which you can silence and manipulate what is in this record. So, in any case, it is a tape, it is a book, and each living entity on this planet has its own unique book. But you see, the unique part is a mere paragraph in its last chapter. The rest of the book is heritage, a memory of the family, of the kind, of all life itself and the planet it is. So the full memory of that has happened on this planet is actually kept by the entire biosphere, not by the individuals, but the biosphere, which is in a sense the scale of the whole planet. It is the planet in a sense. And we think of this interconnectedness between what is preserved in the DNA of individual species together as the tree of life. the tree of life which branches out from a root in the middle, or at the bottom here, and shows you how we can read the changes that occurred in that record as branching out into individual species. We know very well how to design and recreate those branches. What we don't know is when this happened. DNA or RNA, they don't have an internal clock that tells us this happened 2.5 billion years ago, or that branching happened 500 million years ago. But that was one of the things which happened in the last few years that biologists and paleobiologists in particularly managed to connect some of the geological record on this planet and what they can measure by studying very carefully the map of those genomes of many, many organisms and put dates on that tree of life. So now we know that this whole branch didn't develop until those two branches had developed, and a particular number of them has produced the oxygen which is in the atmosphere and the oceans of this planet. So you see, now we know that this tree of life has a memory not only of some of the families of the species that exist today on this planet, but also of the planet itself, our planet. And in a sense, look at this tree of life. What exists today is not the tree itself, but only the tips of the branches. This is old history. The tips of the branches is what exists today. So the tree of life is not a tree, it's more of an envelope, if you will, a circle. And in fact, it's proper to think of it as a circle, just like this. This is a tree of life in which all the different species that have been sequenced so far, and they are not that many that we've managed to do, but tenths of thousands so far out of millions, are on the periphery of that circle. And what is in the middle is the interconnected pieces of the tree. We ourselves, humans, on the top left with a tiny, tiny mark there which says you're here. We carry some of that history, that history which goes back to the bacteria and archaea, which remember the time when there was no oxygen in the atmosphere and the oceans. We don't use that history, but it's still in our DNA. But the important thing here is that the tree represents that common memory of our planet, of our living planet. And the tree is really empty in the middle. The middle is just the memory which is well kept and shared among all. And it is a memory which is dynamic and ever-changing. This circle has little hairs which are changing all the time. As we speak, somewhere in New Zealand, perhaps, a bacterium has discovered or mutated in a way in which can use some form of iron to do something which nobody else did before. If that species survives and if somehow everything works fine and others adopt it, then it will become part of that global memory. If it goes, it will go. It will never be remembered. So that dynamical network, which we think of our human memory, our brain, when we call memory, is also representative of what we see there. And for what we can tell about life on this planet, we hope that alien trees of life on other planets might do the same. And in a sense, one of the revelations that science has brought to us is that life, as small as it is and insignificant it is in space, is very resilient and durable, long-lasting in time. It is as old as the planets and the stars. And in addition to that, it has this record, a written memory of its past. And we live in a universe which is generally very young. It will have a lot more that will happen in the future that it has happened since its beginning with the Big Bang. And we think now that there is a good scribe that could record that history in that future. a very insignificant, tiny form of matter which we call life, but very resilient and very long-lasting. One that, as far as we know, is the form of matter with the potential for eternity in the universe we live in. Thank you.